This meeting is being recorded.
All right. Welcome to Bluetooth for Beginners. Um, I feel somewhat qualified to like go through this material because for many years I worked as a PM for Bluetooth teams. Um, that doesn't mean like I know a ton about each specific component. So there's definitely a lot in the spec that I won't cover. But overall, um, welcome to Bluetooth for Beginners. I'm your host Kiran, and I basically worked on various Bluetooth themes across Microsoft and Amazon and Facebook. I had a brief foray where I worked on a cloud service, and then I got roped back into Bluetooth. So I know a lot of, or I feel confident about a lot of high-level information here, but there's bound to be questions. So, save those for the end and we can chat through them. So I do want to go through like pretty much, I think we're going to cover most of Bluetooth. There's going to be some things that we probably won't, but by the end of it, I feel like you should be able to know your way around all the Bluetooth devices that you interact with daily. And you'll be able to understand when new products come out, like how they're using Bluetooth in a new and innovative way. So yeah, let's get right into it. The first major distinction for Bluetooth is between Bluetooth Classic and Bluetooth Low Energy. And I think Kevin, if you have any questions about like any piece here, just like actually I kind of said save them to the end, but you can stop me. I don't want to go too fast.
Okay,
But
sounds good.
basically, Bluetooth Classic is what most people think of when they hear Bluetooth for the first time. Like when someone says, "Hey, I was talking to them on my Bluetooth headphones or headsets," they're generally using Bluetooth Classic. Bluetooth Classic by itself is extremely power efficient. Even though like there's another low energy form of Bluetooth, Bluetooth Classic by itself uses 1% of Wi-Fi's bandwidth and power efficiency. It's got way more bandwidth than Bluetooth Low Energy, but way less bandwidth than Wi-Fi. I think it's like 50. Wi-Fi is like 50 times as fast. You can go like 100 Mbps or more with like some of the newer technologies. Pairing is sort of slow. If you've ever, troubleshooted getting your headphones paired or your keyboard, you know that it sometimes takes time. You have to do like a security match on both sides. Things sometimes it takes multiple seconds. If you ask, some of my family members, it might take minutes having to call people up. But Bluetooth Classic is known for just being tough with pairing. Whereas Bluetooth Low Energy, they actually fix a lot of these things. There's quick connections. Pairing has been streamlined quite a bit. So that is pretty cool. And
Is
then
there
finally,
is there anything inherent in Bluetooth Classic that makes pairing slow? Or is it just legacy? Like you can't change the spec, and so like this is why like you can't get. Is there a possibility for Bluetooth Classic to have good pairing?
yeah, I mean, I actually think you'll find that a lot of the challenges come from legacy because so we're on Bluetooth, I think like 5.2 or we're on a later version of Bluetooth, but the majority of Bluetooth devices are still on Bluetooth 2.1. And that's the majority of Bluetooth Classic devices even today. Like they'll kind of say that they're Bluetooth 4.2 spec compliant, but really they're using the older pairing mechanisms, the older connection procedures. Today, there's actually really clever ways of connecting over Bluetooth Low Energy and then doing all the pin compares and stuff on a side channel and then pairing. It's called cross transport key derivation. So you can do all sorts of things like that. A lot of devices have not implemented that. I mean, the iPhone was like the first phone to, I think, implement CTKD. And once the iPhone implements a profile, generally you'll see more adoption, but even that's fairly slow.
Got
Yeah,
it.
I think you've probably run into Bluetooth low energy devices. So as opposed to the headphones and headsets, but like your Bluetooth keyboards are generally Bluetooth low energy. They're hit over GATT. And I'm gonna go into a couple of these acronyms later, but Bluetooth is just an acronym soup, so you can always look these up. But like heart rate monitors, a lot of health devices need to last a long time, so they use Bluetooth low energy. This is a overall look at a Bluetooth device. So this is like, picture this as one big Bluetooth device, like a phone or a headset. They usually have two chips. I mean, there are many chips, but like the two that we care about are the host and the controller. The host is actually is what I'm calling the application processor. So like in an iPhone, it's what is it? It's like an A14, right? And then the Bluetooth controller is the dedicated Bluetooth chip. On an iPhone, I think it's called a W1, or they have a specific wireless module. But yeah, so there's a host and there's a controller. They're usually they're connected by a host controller interface. And this is actually some pretty useful, where a lot of useful logging occurs. And so if we break these up, there's a lot going on here. So there's like a lot of layers within Bluetooth. And the thing about Bluetooth that differs from many other specs that are kind of industry standards is that other industries will take just one horizontal component and define it. And then they kind of assume that the transports above and below them are abstracted away, or that they can be interchanged. Bluetooth is, I think, one of the few protocols that has been kind of spec'd all the way from the physical layer. That's literally, how the antenna needs to vibrate, all the way up to the application layer. So how people need to write apps on the phones to talk to a Bluetooth device. So there's literally a spec for each of these. And so you can, I think I've roughly mapped the Bluetooth spec. So if you go look at it, it's similar to this. Just like highlighting a couple of major topics. I think we talked about the physical layer. It's the antenna. Bluetooth actually, the Bluetooth core spec specs out the antenna dimensions and how things need to be scheduled on the antenna. There's the link layer and controller adaptation. Controller adaptation protocol. The L2 cap basically is the component in the host that manages connections to remote Bluetooth devices. So say your phone is connected to 3 different, like a headset, a pair of headphones, and then maybe a Bluetooth mouse or something. You use it on your iPad. All those links will be specified and allow the iPhone or iPad to reconnect to those devices. So that's specified in the link in the L2 cap layer. Most devices need to do service discovery. So SDP and SMP is all about discovering what the other remote device supports and then making sure that you speak the same language. So when a phone connects to a headset, the phone tells the headset that I support a whole host of things. Like I can support contacts and audio and the hands-free profile. And the headset's just going to reply back saying, hey, I only support hands-free profile. Let's talk just for that particular profile. So that all happens on SDP. Security Manager is the security version of that, in my opinion. So it's saying, I support all these security protocols. As a remote device, what are the security protocols you support? And then there's a negotiation there.
One question.
Yeah.
For SDP, like Bluetooth devices, they're used for all sorts of things. Like nowadays, it's like find my dog or like read my heart rate. will those be communicated over STP, or like how do people add arbitrary new functionality? Is that on the application layer or is that on the STP?
It's on the application layer. So generally in SDP, you will specify that I support one or more custom profiles. And those custom profiles are written on top of GAT and AT, and then RFCOM. There are lots of profiles that are also written by the Bluetooth special interest group. So they're the people who own the spec. But all that SDP will say is, hey, I support this custom protocol. And then it's up to the two devices to separately implement this the custom spec, right? So there's no dynamic, there's no like dynamic types almost, right? Where you can like tell a device the type of information as well as the frequency and like negotiate the profile. That all has to happen. It's more statically generated. So
Okay.
does that make sense? Like, yeah, it's all stacked outside.
Kind of. So I guess like what I'm trying to get at is like the profiles that are exchanged. Is that like agreed upon beforehand? Did the consortium have like a finite list of profiles, or is it just like everyone has their own profiles, and if the two devices happen to do have an exact match, then we know that's okay?
It's a mix of both, right? Because there's like close to 100 profiles that the consortium, that the Bluetooth SIG has specified. And so those have defined attributes. And you basically, in SDP, you say, hey, I support heart rate profile and temperature profile. Those are actual, they're defined by the Bluetooth SIG. Separately, also in SDP, you can basically pick a random 128-bit UUID and say, hey, I support this custom profile as well. And it's up to both devices to separately negotiate what that profile means. But at the SDP layer, you're just telling a device, hey, I support this custom profile.
Got it.
Yeah. And the way you basically define a custom profile is also specified, right? It's not like the SIG just says, you know, you have free reign, but it's a pretty extensible thing. The way most Bluetooth low energy custom profiles are supported, and like this is the vast majority of custom profiles, I'd argue, are on Bluetooth low energy. For example, like Strava integrates with a bunch of heart rate monitors. The heart rate monitors support the generic heart rate profile, which is specified, but they also have their own special, like, hey, we also do a special cadence monitoring that is not completely specified. So they'll have a specific data structure. And that for Bluetooth low energy, it's primarily in the GAT and AT layers. All this is talking about, and we'll go through that in a second, is describing a bunch of attributes. It kind of looks like an XML document of services, characteristics, and descriptors of these characteristics. And the characteristics can have a value and a type, but it's basically a large, like an XML scheme of how to exchange data. But Bluetooth Classic generally uses RFCOM. RFCOM is basically a RF communication, but serial port profile. So it's like a pipe that you can use stream data between both devices. So that's how, like, these are the two kind of generic layers, and then a lot of the custom profiles are written on top of these, and then a lot of the Bluetooth SIG profiles are also written on top of these. But there are a couple others, and we kind of talked through this, but like the apps are written on top of the profiles. So like if I were to write a heart rate monitor app today, I would support the heart rate profile, but then I would also, try and do some sort of custom thing. Otherwise, why would someone pick my app over someone else's? So like, I know like Nike has a specific shoe that you can, tighten and release the tightness of the shoe. There's no custom shoe protocol in Bluetooth. So they've defined an app that implements a custom profile, and their shoe implements that custom profile as well. And then finally, we're going to get into generic access, but the gap layer allows two devices to set up does the initial setup of the connection. So it defines like the advertisement packet and then what to look for, and then how scanning needs to work. The two generic layers we talked about just now, there's two major points of LE that I wanted to touch on. One is the GATT profile. So you'll see this a lot if you start working with Bluetooth Low Energy devices. And there's two major types of devices inside the GATT layer, servers and clients. And these follow like the industry terms for this, but basically server has the data, client needs the data. And the server gets to define the schema, right? Do I support the battery service, heart rate service, and then what characteristics I support. And then the client discovers those attributes and reads from it. The other, I think the other axis really is called generic access profile. You saw that on the top left. But this basically defines which device sets up the connection. The central scans for nearby devices, whereas a peripheral broadcasts. So generally my phones are central devices. And then the mice or keyboard are these peripheral devices. And these are kind of spec'd out, but it basically results in this sort of interaction, right? Client server and then central peripheral. And it's really a 2x2 matrix. So every device that you interact with in Bluetooth Low Energy roughly conforms to this. So I don't want to go through the full quiz now, but you can kind of like check and then test yourself. I've underlined a particular device or system, and then it fits into each of these buckets. So the Strava app, I'm not going to quiz you, Kevin. We're just going to go into each bucket. But the Strava app is operating in a central client mode. A smartwatch getting a text message. It doesn't have the text message, so it's the client, and then it is likely the one that is broadcasting because your phone connects to it. So it'll be in the bottom left corner, right? So it's a client peripheral. Mm-hmm. Pedometer has the data, and then is the one getting connected to, and then a pair of headphones sending some BLE data is also a server because it's got voice data, and then an iPhone sending like text message notifications. That's the server. And you can see roughly like along the diagonals, these are the devices that talk to each other, right? A central server talks to a peripheral client. Just a quick sidebar on the Bluetooth Low Energy advertisement packet. This is one of the key technological shifts within Bluetooth. It's not a shift. It's like, yeah, it's one of the innovative things that Bluetooth has come out with over the last few years. But it's enabled a lot of different scenarios. The three major ones are discovery, proximity, and tracking. So I think you mentioned like a dog finder device or something like that. A lot of like Tile uses the Bluetooth advertisement packet to figure out if a tile is in range. They're all using Bluetooth Low Energy. Some of the more, I think Amazon came out with its own longer ranged system, but in the end, it is one device broadcasting and the other one receiving. And it can be broken up. There's a lot of payload, but I think the main takeaway from this is the Bluetooth advertisement packet is really tiny. It's only 31 bytes of data that is, broadcasted at regular intervals. But it can be very power efficient because it only needs to be broadcast a few times. There's a couple of, yeah.
Can a Bluetooth device be both client and a server, or is it only, or is that not the thing?
Yeah, it can be, but it's connection specific. So for a particular connection, you kind of have to pick if you're a server or client. And then for a connection on another service, you can switch. The primary case is smartwatches, right? Sometimes a smartwatch might have you can detect the battery level of the smartwatch, but you also send notifications to it. In that case, the smartwatch and the phone, they support multiple services, and the server role is like the smartwatch is a server for the notifications, and it's a client for the I think I got the mix. It's a client for the notifications, and it's a server for the battery indication.
Got it.
All right. More on the advertisement packet. I think this is just purely a security thing, but you'll see a lot of randomized advertisement. You shouldn't feel like every Bluetooth device is advertising. So it's easy to track people based on Bluetooth devices. That actually used to be the case, I think, 10 years ago. But over time, most devices have started randomizing the advertisement packet. So it's extremely hard to, just set up a broad listener of advertisement packets and figure out where people are going. But yeah, this is one of the good security measures that Bluetooth is.
When you say randomized, does that mean that like the ID that it broadcasts like changes, or like what exactly is being randomized?
Yeah, so it's the MAC address. So like usually there's a physical MAC address that is burned into the system that you have to go get from the IEEE. For a random address, it'll actually mask that and then rotate it over time. So like they do an initial, if it's connected to a different device, it will negotiate just like an authenticator app, right? Like they negotiate the time periods when they're rotating, but they're mainly rotating the MAC address. I think you're also hitting on a good point where like, if you just had a constant advertisement packet, like the payload was constant, then we'd be back to square one. That's generally not the case. They actually like the data also changes over time. And I think most of the device finding applications also do their own rotating of the data as well. But yeah, it's mostly the MAC address. I'm going to quickly go through a brief history. And I think it's kind of wild to go through this because, Bluetooth's just been around for a long time in the technology world. Like Bluetooth 2.1, I think, came out in like early 2000s. But it also shows how long things take to get adopted. Bluetooth 4.0 came out in 2010, but we only had large-scale industry adoption by 2014 or 2015. So it takes, 3 to 5 years, I would say. Bluetooth 4.1, 4.0 shipped with a lot of rough edges. And so like it was really hard for a single device to support both Bluetooth Low Energy and Bluetooth Classic, even though the protocol was designed to be supported on the same physical hardware. So Bluetooth 4.1 added dual mode topology, which is both of those acting together. The randomized addresses we talked about, LE Privacy 1.1. They needed more support for custom UUIDs, so custom characteristics and protocol, custom attributes, and that's the 32-bit UUID support. But basically 4.1 is, I think when most people say they've implemented Bluetooth Low Energy, they've implemented 4.1 at this point. There's more security measures in 4.2, so that was like a year later. These are a couple of fast follow releases, really. The major one that's come out relatively recently And we're really seeing the impacts of this now. And going forward, I think there's a lot of applications for Bluetooth 5.0. And here they basically took a lot of the learning that we had with low energy and then applied it to a much more powerful physical layer. So they changed a lot of the underlying radio technology too, so that low energy, so that the power implications for low energy can be met even at for a longer range or a higher throughput. So they basically, this was a step change from 4.0 in 2010. I think the major applications that we're starting to see now is like industrial lighting and automations. You'll see a lot of this on the industry side. In consumer tech, there is a lot of smart home technology coming out. The best stuff I've seen has been when builders just like put all the smart home technology in a house for you, because it's still rough edges if you were to go and buy a bunch of off-the-shelf components. I did this myself with Z-Wave technology, and that's actually a little bit further along because Z-Wave is just, they've implemented a mesh protocol much earlier. But I think Bluetooth mesh, just from the industry support and how many chip manufacturers already make Bluetooth chips, I think it's going to be a lot bigger in the future. So yeah, that I think is like an overview of the state of the world with Bluetooth. I don't know, I've revamped it a little bit, but some of this information could be dated pretty soon. Technology moves quickly, but we basically walk through the differences between classic LE, all the profiles, roles, and how devices work. So yeah, thanks for listening. Did you have any other questions?
Presentation. The one that comes to mind is, you talked about how things move slowly and this is 3.5 adoption period. Bluetooth 5.0 was 2016. Like, what are we on now? What came out in 2020? What will it look like 5 years from now?
Yeah, it's a good question. I mean, after Bluetooth 5.0, there's a bunch of like smaller releases that I didn't include because they didn't include a bunch of new features. They were, I almost view them as like, and if the Bluetooth SIG hears this, and I mean, there's probably a couple features that is extremely well received, but I think they were all smaller, minor updates. I think the most important thing right now is getting adoption for 5.0. And the way it looks 5 years from now is more power efficiency with longer range for all these devices. I think they've like that's their key metrics for Bluetooth. How power efficient can we be with how much range, and then with a particular throughput. So between those three axes, every time we improve, there's a step change. Like one of the coolest things we could do with 5.0, and I think this is actually more recent than 5.0 because it took even more changes at the physical layer, is they can do hearing aids through Bluetooth Low Energy, which means you can have extremely power efficient devices that just sit in your ear for days. And because it has Bluetooth, they're experimenting with a TV connecting directly to the hearing aid, so it doesn't disturb other people around them, so that just their sound can be boosted, just for hearing impaired folks. So there's a lot of new technology that improves. And I think that's more at the scenario level, but at the basic technology level, they're always trying to improve it along those axes.
Got it. And then I guess my other thought here is like, there's a bunch of different wireless specs and technologies. I mean, like in my house, things connect either via Bluetooth or via Wi-Fi. And like, it sounds like Bluetooth now, like a lot of what it's evolving into is this like long range, like neighborhood wide kind of coverage, which to me, it starts getting into like, supposedly 5G or 4G or the cell towers also offer this kind of similar benefit. I
Yeah.
guess like in the future, like because it seems like it's possible to use both interchangeably to some degree. Um, like what is the advantage? Like if everything in my house is like connected anyways, like using Bluetooth or using Wi-Fi, and like on a neighborhood level, if we have ubiquitous 5G or Starlink or whatever it is, and anything is available to a Wi-Fi signal, like what would the difference be between using Bluetooth versus the Wi-Fi?
Yeah, it's a good question because they're both 2.4 gigahertz. And as these chips get more power efficient, Wi-Fi is also getting more power efficient. Um, I think where you'll see Bluetooths continue to have a niche or have most of the market is in battery powered devices. So like if you were to have, if the promise of smart cities where you've got sensors in the road that are like extremely power efficient and don't get changed that often, or smart lighting where maybe they're just like solar powered LEDs that you don't always want them connected to the grid. That's where I think Bluetooth Low Energy will start shining. For things that are always connected to power, I think you're absolutely right. Like ubiquitous 5G will just connect them to the internet. There's no reason like smart lighting, I think, would necessarily stay on Bluetooth. But I could be wrong. But today, switches and smart lights are all over Z-Wave, which is a similar protocol to Bluetooth Mesh. Um, but I don't think they need to be so power efficient because they're just connected to the wall. So I think they'll start directly connecting to the internet. So you can just plug them in and they just start working. And you don't have to worry about, a pairing process.
Makes sense. Okay, and last question is, how do you see Bluetooth being integrated with Dendron?
Oh man, I knew this question was coming. I was actually, when I was looking at the Bluetooth spec, I think like it would actually make a pretty nice vault because I I have downloaded this massive PDF onto my computer many times, and it's kind of painful to work with. And then all the track changes, like being able to uh, have the Bluetooth spec open sourced, and it's publicly available uh, with people proposing changes and stuff, and then adding questions, building a knowledge base around Bluetooth. That I think would be like the first step. But man, if I put my crazy tinker hat on, I think it'd be pretty cool to literally have peripherals that implement a Dendron specific protocol. But I think that's literally from like when my vault is syncing or like when vault operations are happening, it can like flash lights or like it can have a status indicator. Like when my vault's not up to date anymore compared to the remote vault, that'd be kind of cool. I've seen things like that do that. But man, what do you think after you've heard this?
Yeah, it's like the light indicator. I also like the just putting the docs in Dendron. Something it's making me think of is we should have the PDF to Dendron pod because so much stuff is like locked into PDFs, and it's actually pretty not that hard to do that nowadays. The other thing I'm thinking is because so many of our peripherals are using Bluetooth to broadcast,
Yeah,
that it would be really cool, like on the having like a Dendron profile to just like have a little module that you plug in that basically sucks up all the advertisement packets and can store that in a structured way. So if you think about because like today, like Dendron, it's mostly for like human like docs and notes, but you can also imagine Dendron being used like we have key value stores in the front matter of being able to take you know your heart rate output and your other output, and then also combining that with the data that you have, like maybe with your daily journals and whatnot. Like the people from Quantum by itself, like all they do is like they collect data from these sensors. But it would be cool to have our own custom profile to be able to do that automatically.
yeah. I mean, I think logging is such a huge use case for this because especially with Bluetooth, I think half my life was just collecting logs for random specific scenarios, and we would like troubleshoot them. Having a way to organize, store them, and so you can read them later in a clear way, that would be pretty big. Well,
All right.
I think the future is bright for Dendron and Bluetooth. That's all I have to say on that note.
Well, sounds good. Good to know that we have a Bluetooth expert in the house, so we'll know who to ask for when we're in need of Bluetooth features.
Yeah. Yes, you do. Thanks. See ya.
Okay, cool. Thanks. Later.
See ya.